Hello, in this discussion we'll be talking about the sum and difference formulas involving inverse trigonometric functions. So let's begin with an example. So we want to find the exact value of the cosine of the sine inverse of 2/3 plus tangent inverse of -3/4. And we're letting that equal the cosine of alpha plus beta. Okay, so what we're going to do is let alpha be the sine inverse and we're going to let beta be the tangent inverse. These are kind of one of my favorite type of problems because it's kind of like to me it's like a little puzzle. So you're trying to evaluate cosine of alpha plus beta when alpha and beta are those two inverse trig functions. So let's begin with the alpha. So alpha is the sine inverse of 2/3. So that means the sine of alpha is 2/3. Alrighty? And so what that means is cosine of alpha is 3/5, square root of 5 divided by 3. Now, why is that true? Well, by the Pythagorean identity, sine squared plus cosine squared equals 1, okay, the cosine of alpha would be the square root of 5 over 3. Now, technically, it would be a plus or minus, but we know alpha is in the first quadrant because the sine inverse of 2/3, since the ratio is 2/3 and it's positive, that means it's in the first quadrant. So therefore cosine is also positive. So that's the reason. So that's the first one. Now the beta. So the beta is the tangent inverse of -3/4, which means what? The tangent of beta is a -3/4. So I need to know what the sine of beta is, and I know what the cosine of beta is. And you're like, well, why do you need to know that? Because I'm trying to evaluate cosine of alpha plus beta, and if you remember the summation formula for cosine, you need all of those. So that means the sine of beta is -3/5, and the cosine of beta is 4/5. And you're like, well, how do you know that? Well, you could figure out the secant of beta first by using the 1 plus tangent squared equals secant squared to find the secant. Then that finds your cosine. And then once you find your cosine, you can find your sine by the Pythagorean identity. Now, there's a much easier way than that. You could just create a triangle and say, well, the tangent beta is 3/4, so it's opposite over adjacent. And that would make the hypotenuse 5 by the Pythagorean theorem. And then using your right triangle trigonometry, you can find those values just as easily, if not quicker, that way. Now, but I do want you to notice that the sine of beta is a negative and the cosine is a positive 4/5 too. Now, what about the sines? Well, the tangent is a -3/4, and if you apply the inverse tangent, you're either in the first quadrant or the fourth quadrant. And so, since it's negative, you'd be in the fourth quadrant. And if you're in the fourth quadrant, sine is negative. Cosine is positive, though. So that's why the sines are the way they are. All right. So now that I've got all the angles and the trig functions at sine and cosine, it's just a matter of evaluating the cosine of alpha plus beta. And remember that the cosine of alpha plus beta is the cosine of alpha, and I have it. Cosine of beta, I have it. Minus the sine of alpha, I have it. And then the sine of beta, and I have that one as well now. So just pop those numbers into the formula. And then you get square root of 5 times 4, which is 4√5 over 15, plus 6 over 15 because two negatives make a positive. So it turns out to be the 4√5 plus 6 all over 15 under the same fraction. So pretty neat things. I mean, so you can evaluate that with and get an exact value. Some people would see that first problem and say, well, cosine of sine inverse of 2/3, can't you just put that into a calculator? You can't. And it would give you an answer. It'll give you a decimal answer. And that decimal answer in exact form is 4√5 plus 6 over 15. And notice what the instruction says. Find the exact value, which basically means throw out your calculator. You don't get to use it here. So this is what you would have to do. If it just says find the value of that, then your calculator would be fine. So, but anyway, so what you do here is you just apply inverse trig functions to figure out the rest of your trig functions evaluated at alpha and beta. Alrighty, so Pretty nifty little item there. Now let's look at this one. Writing a trig expression as an algebraic expression. Now this is kind of on the same lines as what we just did in the previous example, except the ratios are not there. They're just u and v in this case. But the process is exactly the same. So what we're going to do is we're going to let your alpha and beta be equal to those trig functions. So what we're going to do is first, for sine inverse of u, we have u is between -1 to 1, because remember you can only take the sine inverse between those. And for cosine inverse, it's also between -1 to 1. So therefore, u is, they're letting alpha be the sine inverse of u, and beta be the cosine inverse of v. So it's very similar to the previous example. So therefore, the sine of alpha is u, and the cosine of beta is v. So rewriting without the inverse function. So therefore, since that cosine of alpha is greater than or equal to 0 because it's u, as a result, cosine of alpha is equals to the square root of 1 minus the sine squared of alpha. So therefore, cosine of alpha is the square root of 1 minus u squared. Now, and the reason you need that is because in order to find the sine of alpha plus beta, you need all two of the trig functions, sine and cosine, evaluated at alpha and beta. Now, similarly for the other one, sine of beta is the square root of 1 minus the cosine squared of beta, which is equals to the square root of 1 minus v squared. So you've just found cosine of alpha, you've just found the sine of beta, you already know the sine of alpha and the cosine of beta. So as a result, the sine of the sine inverse of u plus the cosine inverse of v is the sine of alpha plus beta. And now by the addition formula for sine, that would be the sine of alpha, cosine of beta, plus the cosine of alpha, sine of beta. So what is the sine of alpha? Oh, that was u. What was the cosine of beta? Oh, that was v. Plus cosine of u, remember that is going to be the square root of 1 minus u squared, and the sine of beta is the square root of 1 minus v squared. So it's just a matter, that last step, is just a matter of going up above in the screen there and plopping in those values. And then you cannot simplify it. So you cannot simplify u and v, you cannot simplify the square root of 1 minus u squared times 1 minus v squared. I mean, technically, I guess you could put those two square roots together, but that would be really unnecessary work. So the bottom line here is you need to be able to evaluate the sine of alpha plus beta by using the summation formula for sine, and then but you have to know all 4 of those trig functions at those values. And that was what the middle work is about. Alrighty? So if you have any questions on this one, let me know, and we can maybe come up with a different example, and you have a good day.